Recall that the ideal gas law was for an ideal situation where the gas particles were spread out, moving at random velocities, and the volume of the gas particle is negligible compared to the volume of the gas. So an example of an ideal condition is a low pressure and high temperature, where the molecules fly around fast enough so the intermolecular forces don't have much influence on the behaviour of the gas. And these intermolecular forces are mainly responsible for the deviation of the gas from ideal behaviour. So if we look at scenario 1 where we compress the piston such that the volume of the gas gets smaller, then the volume of the gas particles is no longer negligible compared to the volume of the gas. So given that the ideal gas law assumes that the gas particle is a point, so therefore the volume of an ideal gas particle is smaller than the volume of the real gas particle. And therefore the pressure of the real gas is greater than that of the ideal gas. Now the other situation is where you have a low temperature, so the gas particles travel around at smaller velocities and the intermolecular forces become significant. So at this situation, which is near condensation conditions, where the gas transitions from a gas to a liquid, then droplets are formed due to the significance of the intermolecular forces, and therefore the gas particles bump into each other in the walls of the container less often. So the pressure of the real gas would be lower than the pressure of the ideal gas, which ignores the intermolecular forces.